Hey guys, welcome to another episode about cryptography with Openssl. So subject for today it's block-cipher mode. So first thing what we are going to do, type Openssl, ENC, that stands for encryption, and command list. In here you are going to see a list of all supported algorithms. And if you check every single element, you are going to see that is composed of multiple parts. So first part, it's actually a name of algorithm itself. Second part, it's key size. And third part, it's block-cipher mode. Well, today I'm not going to talk about algorithms and key sizes, but there is something that I absolutely must explain in order to proceed, and that is block size. Well, what is all about? Algorithm is processing your input data in blocks. What that actually means? First of all, block size is not the same in every algorithm. But nonetheless, if input text is smaller than block size, then algorithm introduces padding. It means that fills the gap in between end of content and end of block. But if your content is, for example, much bigger than block size, then algorithm needs to split that content into chunks that are going to be equal to block size. The last chunk of data is usually smaller than block size. So with last chunk, algorithm uses padding only if necessary. And finally, how encryption process is going to proceed depends on block-cipher mode. And for today's episode, I'm going to explain multiple modes. I'm going to explain ECB. It's in here, that stands for electronic code book. This is the simplest one. Then I'm going to explain CBC, that stands for cipher block chaining, that is most commonly used. Then I'm going to explain CTR, that is a little bit better than CBC in regards of parallelization. And finally, for streaming, I'm going to explain this CFB, that stands for cipher feedback. And by the way, CTR stands for counter. And the last one is going to be OFB, that stands for output feedback. So now let's say a few words about ECB, this first one. With ECB process, it's really simple. We are splitting input content into blocks. Then we are feeding every block to encryption algorithm with key provided. That process produces ciphertext for particular block. And then at the end of every ciphertext block, we are attaching ciphertext of the next block. And as I said, this is very simple way to do encryption. And by the way, very easy to parallelize, but not very safe. Why? Because if you have some huge content, especially if there is a lot of repetition in that content, you are going to get a lot of repetition into ciphertext, which could be very bad in regards of security. But for example, if content that you want to encrypt, it's smaller than block size, you could freely use ECB, doesn't matter. Much better cipher block mode, it's this one, CBC. As I said, that stands for cipher block chaining. And in this case, we have to introduce additional parameter called IV, or initialization vector. So in this case, we are XORing input content, and then product of that process is provided to encryption algorithm with key. And then finally we are getting ciphertext, but then ciphertext of our first block is going to be provided as initialization vector for next block. So this is a much better way to do encryption, but with one really serious problem. With CBC you cannot do parallelization, because in order to encrypt every block you need ciphertext of previous block. And because of that very same reason, another mode is invented, CTR or counter. With CTR we are not using initialize vector, instead we are using counter. Counter is provided as value to encryption algorithm. Then result of that process is XORed with input block. And as a result of that XORing process, we are getting ciphertext. For every next block, we are just going to increment that very same counter, which makes this method really good in regards of removing of repetition and for allowing parallelization. And finally, we are going to mention two modes for streaming. So first is CFB. CFB stands for cipher feedback. In this case, we have initialization vector that is provided to encryption algorithm. But then only first 8 bits from that process are used. Rest is discarded. Why? Because with streaming we are processing 8 by 8 bits. Then we are going to XOR these 8 bits with input block in order to get our ciphertext. But for the next block, that ciphertext is provided to shift register. And first thing that is done is shifting 8 bits left. But now, in case of OFB, there is really small difference. So first we are providing initialize vector to encryption algorithm. Of course, then we are using first 8 bits, rest is discarded. And that value is provided to shifting algorithm for the next block. With first block, we are continuing this process by XORing these 8 bits with input block, in which way we are getting ciphertext. So guys, this is a long story short about block cipher modes. And of course, if you want to become master of this subject, you will have to invest a lot more work and a lot more time into studying. But for the beginning, I believe that this small explanation is going to serve you well. And as always, I hope that you have learned something interesting, so please like, subscribe and see ya!